All right. So this will be the beginning of our lecture on primate diet, primate locomotion, and primate sexual dimorphism. So some of this information will be a little bit of a review from the classification section, but this topic is something we call comparative osteology. So basically, what information can we gather from looking at bones, looking at teeth, looking at the length of bones, the robusticity of bones, the shape of the dentition, the shape of the craniofacial shape. So what information can we gather by looking at bones and teeth, essentially, is what we mean by comparative osteology. All right, so let's talk diet first. So as I mentioned in the previous lecture, one of the things that defines a primate is our dietary plasticity, or the flexibility and variety in our diet, which, as we know, is extremely adaptive. Being able to switch food resources in times of shortage means that we may survive during famine and drought, for example. So an insectivore is simply a primate that focuses mainly on insects, just like it sounds. So a diet that emphasizes insects. These tend to be small-bodied primates because these little insects are like little pockets of energy. So you can imagine that even though insects are good sources of protein, they're tiny, right? So you have to eat a lot of them to get enough protein, and you have to have a small body size so that you don't need to consume a large quantity of them to survive. So the primate groups that we find are insectivores are mainly the lemurs, the lorises, the tarsiers, and the marmosets. You'll see a tarsier featured in this PowerPoint slide here. So their molars, when you're looking at their teeth, so they're really tiny and really sharp and pointy. So they're sharp and pointy because they're using those pointy dentition, those pointy teeth, to break open the insect exoskeletons. Also, insects are really easy to digest, so the digestive tracts of insectivores are relatively simple. Okay, so small-bodied primates, small pockets of energy, really sharp, pointy teeth, and tend to be those lower order, the lemurs and the lorises, and then also the tarsiers, which tarsiers are actually haplorhines, and then marmosets are New World monkeys, but they're very small-bodied New World monkeys. All right, next dietary type is called gumnivory. So a lot of times, primates that eat insects also eat something called tree gum or tree sap. So essentially, the sap will ooze out of the bark of a stem or trunk. These are also generally little small bursts of energy. And this feature called the tooth comb, which we talked a little bit about last lecture, but this tooth comb is that dentition, the lower dentition that's jutting straight forward. So you're looking at the mandible here, and those incisors and canines are together like a comb. That's why it's called the tooth comb, and they're jutting straight forward. So they use the tooth comb for a couple purposes, for grooming and also to puncture the tree bark to extract that tree gum or sap. Okay, so little small bursts of energy, just like the insects are, and they tend to be small-bodied primates like the lemurs and the lorises. Okay, so sometimes they will supplement their diet with insects for additional protein. Okay, so gumnivores, primates that consume mainly tree gum, small-bodied primates like the lemurs and lorises. They tend to have small mandibles and jaw muscles. Most of them will have that feature called the tooth comb that allows them to puncture the tree bark to get the gum or sap. And they will occasionally supplement their diet with insects for additional protein. So that's a gumnivore. All right, next dietary specialization type is going to be a folivivore. So our best example of the folivivore, the vegetarian, is our friend the gorilla. So that just simply means a diet that emphasizes leaves or foliage and other plant parts such as stems. This dietary type requires really extensive chewing. So best way to understand this, imagine eating raw celery or spinach, which requires really intensive chewing to break through those plant fibers. And then also imagine that you have a very large body size. So the larger the body size, the higher the caloric demand. So these gorillas are spending a large portion of their day just chomping on vegetation. So their molars, you probably won't be able to see it clearly in Zoom, but their molars have these shearing crests here that allow them to kind of shred and shear that vegetation. They have large mandibles and jaw muscles. So essentially, like I mentioned, the gorilla has a massive jaw, this really pronounced ramus here. So the jaw muscle for the gorilla begins here at the ramus. It tucks underneath the zygomatic bones and then attaches all the way up here at the sagittal crest. So for comparison, our jaw muscles stop just right above our ears here because we have a much softer diet and we also cook our food to soften it prior to consumption. Okay, so the sagittal crest is something that you see in mainly folivivores. Gorillas are folivores, colobus monkeys, and howler monkeys. Okay, colobus monkeys and howler monkeys don't have the sagittal crest. Sometimes howler monkeys have a slight one, but the reason they don't is because even though they're folivivores, they have pretty small body sizes. So their jaw muscles don't need to be quite as massive as the gorillas does. All right, next dietary specialization type. Frugivores. So just like it sounds, a frugivore is going to consume a diet that emphasizes mainly fruit. Okay, so fruit, kind of like insects, are really easy to digest, but they provide a little bit more energy than, say, an insect does. They provide an intermediate or a medium amount of energy. So because they provide a medium amount of energy, these tend to be medium-bodied primates. So they have molars that have really low rounded cusps that act like juicers to squeeze fruit and reduce pulp. So they have kind of like a built-in juicer in their mouths. They have a medium-sized mandible. This is the most common specialization that we see in the primates. Most primates eat fruit to some degree. And some examples of primate species that we consider platyrrhines, that we consider frugivores, would be most of the platyrrhines, cercopithecoids, gibbons, orangutans, and some lemurs and lorises. So we talked about insectivores, eating mainly insects, gumivores, eating mainly tree gum, folivivores, eating mainly vegetation, and frugivores, eating mainly fruits. All right, so exactly what else can we determine from teeth? And that seems like a very small piece of evidence, but you can determine a lot by looking at the teeth. You can determine oftentimes the approximate age of the primate because teeth, the adult teeth will erupt from the gums in a predictable manner. So if you understand those dental eruption rates, and there's charts that we use as anthropologists, if you understand those dental eruption rates, you can estimate the age of the primate, especially if it's a juvenile. You can look at the attrition or the tooth wear to determine information about diet and how much they use their teeth. And also, if there's a lot of wear, you're likely looking at an older adult primate versus a juvenile. You can also sometimes determine biological sex, especially in those primate species that have really sexually dimorphic canines. So the gorilla is another great example. I don't have a female on me right now, but our male gorilla here has this really pronounced canine size. So that's one of those features that we consider sexually dimorphic. So that term sexual dimorphism, to recall from the human adaptation chapter, just simply means differences in the characteristics between adult males and females of the same species. So sexually dimorphic canines means that the males are going to have really predominant, projecting, intense canines in comparison to the females. And that is generally related to sexual reproduction and competition rather than diet. So when you see these really sexually dimorphic canines, the gelada baboons that we'll watch later today are another great example. I'll point those out when that video clip comes up. But sexually dimorphic canines means that there's likely a polygynous mating strategy and likely high levels of competition for access to mates. You can sometimes determine the health of the individual, especially if we're looking at humans and we're determining, are there a lot of dental caries or cavities and abscesses can reflect dental health and general nutrition. It can sometimes determine mating systems. Like I mentioned before, canine dimorphism is related to competition for mates and access to reproductively receptive females. So this is a great picture of a gelada here, flaring his upper lip. And you see really large projecting canines here. So when you see that feature, you're likely looking at a polygynous one male, multi-female system with high levels of competition for access to mates. Behavioral part, if you're looking post-cranially now, so we're looking from the neck down. So post-cranially, we can sometimes use the skeleton to determine behavior patterns. So locomotion's a big one. So we can look at the lengths of the bones, the flexibility of the joints, to determine how that primate likely moved. Even if we're not looking at a live primate, we can sometimes use their skeletal anatomy to determine their primary mode of locomotion. And of course, diet. We use teeth to eat stuff, so tooth morphology is an indication of primate diet. All right, so just a little terminology to get out of the way. The term anterior, so anterior means in the front. So like when we talked about anterior facing orbits, those are orbits or eyes that face forward. So anterior dentition is simply the dentition that's in the front of our mouth. Okay, so the incisors and the canines. So think about taking a bite of an apple. So when you take a bite of an apple, that first bite, you're using mainly your anterior dentition, your incisors and your canines. But once you've taken that initial bite, the premolars and the molars are doing most of the work, right? They're doing most of the chewing, the crushing, the grinding. So because of that, the teeth in the back of your mouth, your molars and your premolars, are generally more useful if we're trying to reconstruct dietary adaptations, because the posterior dentition is usually primarily in charge of that functionality, okay? Primarily in charge of the crushing and grinding and most of the mechanical force that goes on with chewing, okay? So usually if you're interested in diet, the posterior dentition, the premolars and molars are going to give you more info than the incisors and canines. All right, the jaw pressure can also influence skull form. So the factors that influence skull development will be the size and the shape of the chewing muscles, the magnitude of that chewing force, and also the direction of the chewing force. So for the gorilla, our good friend the gorilla, we've got that sagittal crest. We've got the temporalis muscle that starts down here. Well, the masseter muscle starts down here at the mandible, ramus, tucks underneath the zygomatic bone, and then connects all the way up here at the sagittal crest. So the diet of the gorilla, that crushing and grinding force, not only affects the teeth, but also the craniofacial shape and the skull form. Okay, so we see this sagittal crest here and the nuchal crest is really exclusively related to the fact that they need really powerful jaw muscles for their diet. Kind of interesting, right? That something as simple as their diet can really influence the shape of their entire skull. All right, let's talk a little bit more about locomotion. I know we've touched on this already, but comparative anatomy is all about diet and locomotion. So let's touch on it a little bit more. So locomotion just simply means movement. How is that animal getting from point A to point B? And sometimes they'll use various forms of locomotion, but most primates will have a predominant mode, so a mode that they use most of the time. So a little terminology, the term forelimb just means the upper or front limbs. So it's the humerus, that's the long bone in your upper arm, and then the radius is the bone here, and the ulna is the bone here. The hind limb just simply means the limbs in the back of your body. So for us, our legs. So the lower or back limbs. So for us, it's the femur. Well, not just us, other primates. It's the femur, the bone in our thigh, plus the tibia, that's our shin bone, and then the fibula. That's the long skinny bone that's lateral to the side of the tibia. And then, of course, the term arboreal just means mainly tree dwelling. The term terrestrial means mainly land dwelling. Okay, now that doesn't mean that because it's an arboreal primate, it doesn't occasionally come down to the ground. Of course it does. And terrestrial primates also sometimes go up in the trees. It just means if it's connected to arboreal, it means they spend most of their time in the trees. If it's a terrestrial quadruped, they spend most of their time on the ground. All right, so let's talk about the types. So there's going to be 6 types that we talk about. So these next 2 slides just kind of introduce it, and then the following slides will go into more detail. So there's arboreal quadrupeds. So they tend to have really flexible joints, and they tend to be hind limb dominated, but there's not significant differences. So when you're looking at the spider monkey here, and you see he's moving horizontally, it's a rope here. This is likely a picture from a zoo or a domestic habitat. But you see he's moving horizontally across this rope. So you do see that the hind limbs are slightly longer than the forelimbs, but not significantly, not hugely. So this is a spider monkey moving horizontally across a rope, but you can imagine it was a tree branch. Vertical clingers and leapers. So that's a really unique mode of locomotion. And I'll show you another video clip of it here in a second because it's just fun to watch. But vertical clingers and leapers, they're very vertical in their body posture. And they tend to use their hind limbs to springboard, and they locomote like this. So they're kind of bouncing from branch to branch. They're hind limb dominated, so that means their legs are much longer than their arms. And it's only found in the strepsirrhines / prosimians and in the tarsiers. And then kind of the opposite of vertical clinging and leaping would be brachiation, because they're using predominantly their arms to locomote. So this is found in the apes, mainly in the lesser apes. The lesser apes are the greatest at it. So in this form of locomotion, you'll see that the forelimbs are much longer than the hind limbs. All right, type 4 is going to be terrestrial quadrupedalism. So just like it sounds, they're moving on the ground and they're moving on all fours. So they tend to have more stability in their joints, and they tend to have hind limbs and forelimbs that are equal in length. So we call that shared dominance. Knuckle walking is a form of terrestrial quadrupedalism, just like it sounds, they're just up on their knuckles. And then, of course, bipedalism is something we find, at least obligate bipedalism is exclusively found in humans and our ancestors. All right, a little bit more detail about vertical clinging and leaping. So we know that the body is oriented vertically, and movement occurs by leaping from tree to tree. So this movement is going to look kind of like this. So I'll show you a clip here in a second. So they push off the tree with their legs and leap through the air. They land on another tree branch in an upright clinging position. We see this form of locomotion in some lemurs, lorises, and the tarsiers. And the tarsiers actually got their name. They have an unusual tibia and fibula, so unusual shin bone and the bone right next to the shin bone that kind of act as shock absorbers. All right, so we're going to watch, I know we've already watched one clip on vertical clinging and leaping, but I'm going to show you another one. This is from a documentary. It's an old documentary, but it's one of my favorites. It's John Cleese with the lemurs. I don't know if you guys know who John Cleese is, Monty Python. The whole documentary is a great one. I'm just going to show you a little clip of it, but if you're interested, I can post it for you guys so you can watch the whole thing. It's a pretty cool little documentary. It's a little dated at this point, but this particular part is going to show you shafakas. So shafakas are a species of lemur, and it's going to show you how they're locomoting. Well, let me check on the volume first. Oh, pretty good.
Diet in the most hostile habitat. The reason they can do this is because of their incredible... I'm standing in front of what must be the most glorious example of specialized skills in the lemur world. These are Veroshifakas. Instead of just feeding in the typical forest where they would be in competition with other lemurs, they found a way of supplementing their diet in the most hostile habitat. The reason they can do this is because of their incredible jumping skills. On the outskirts of the main forest lies an area which is only accessible to these leaping lemurs. This is the spiny forest. The trees here are covered with tightly packed thorns, like strands of barbed wire, which the Shifakas have learned to pick their way between. But getting round the spiny forest is where their true skill lies. No one understands exactly how, but the Shifaka can jump sideways over 30 feet with astounding accuracy, landing each time with its toes perfectly placed to avoid the thorns. It's a ballet of spectacular precision. But sooner or later, the Shifakas have to come down to the ground, and then getting around is a different story. Their long legs are built for leaping, their backs for sitting up straight, and their toes for clinging to tree trunks. So in the long process of evolution to become tree-hopping specialists, Shifakas have lost the ability to move on all fours like other lemurs. So they get around by bouncing sideways. They remind me of Edwardian waiters on Menzarine. But in the air or on the ground, the Shifaka's movement has to be one of the most beautiful things I've ever seen.
All right, so I love that little clip because it does. I know it's a little fuzzy because it's an old VHS, probably that somebody turned into a YouTube video. But you really saw how elegant and unique that form of locomotion it really is. So we call that vertical clinging and leaping, and we only find it in the lemurs, the lorises, and the tarsiers. That's called vertical clinging and leaping. And you see how I like that clip too, because you can really see how the hind limbs are extremely dominant. They're really mainly predominantly using their hind limbs. Their arms are just kind of for stabilization. All right, questions about vertical clinging and leaping? All right, next one. So next locomotion type is going to be brachiation. So this is kind of, you can think of it as kind of the opposite of vertical clinging and leaping, because instead of being hind limb dominated, the brachiators are forelimb dominated, meaning that they're using predominantly their arms for locomotion. So this is a form of what we call suspensory locomotion. So they hang or suspend themselves. They swing from branch to branch. They sometimes suspend from branches. They sometimes suspend while eating, by eating fruit. They have very long arms. They have curved phalanges. The phalanges are the finger bones. The gibbons and the siamangs, our lesser apes, are masters at this form of locomotion. This form of locomotion is limited in the great apes simply due to their size, because their body size is obviously much larger than the gibbons and the siamangs. So they essentially are less adept at this particular skill because of their body size. Okay, and it's very possible that our ancestors, and we'll talk about this more once we get into this section, it's very possible that our last common ancestors had limited brachiation form, or abilities, I should say, because evolution occurs over millions of years, especially when you're looking at a species like a human that has a very long lifespan, or a primate. You see that the earliest forms like Ardipithecus and the Australopithecines, even some early members of our genus Homo, tend to have some of these features. They tend to have longer arms, curved phalanges. So it's very possible that our earliest ancestors retained some of this suspensory locomotion. And when you think about it, that's extremely adaptive, because if they're able to locomote and adapt to life in the trees and on the ground, then they can exploit food resources that are in the trees and on the ground. Okay, so that's a very adaptive thing, in my opinion. We'll talk more about that when we get to the human evolution section. All right, next type we're going to talk about arboreal quadrupeds. So my advice, always break that word up. Arboreal simply means tree dwelling. Quadrupedal means movement on all fours. So an arboreal quadruped is simply a primate that moves in the trees on all fours. So you're going to see these primates mainly doing horizontal movements across tree branches. So they walk and run along horizontal surfaces, and then they jump from branch to branch. Just like other primates, they have prehensile hands and feet, but most of them have that additional fifth hand that we call the prehensile tail. So they also tend to have long phalanges because they're also using their phalanges to grasp on to tree branches, bark, other surfaces in the arboreal environment. And they tend to have scapulas, that's their shoulder blades that are kind of lateral on the rib cage. and they tend to have flexibility in their, especially their pectoral girdle. So that's where the humerus connects to the clavicle and scapula. So these are mainly, this form of locomotion is found mainly in the platyrrhines. We do, in some of the smaller old world monkeys, we do see this form of locomotion as well. But we see this in primates like spider monkeys, howler monkeys, capuchin monkeys, tamarins. These are all examples of arboreal quadrupeds. All right, terrestrial quadrupeds. So this is found mainly in the cercopithecoids. So that's that specific type of old world monkey. So the baboons like mandrills and geladas and hamadryas baboons. We find it in macaques, rhesus macaques, Japanese macaques. So they're just like it sounds, they're mainly on the ground and they're moving on all fours. So in comparison to the arboreal quadrupeds, they have really more shared equal dominance because all of those limbs are essentially equally responsible for supporting that primate in their locomotion. Okay, they have forelimbs and hind limbs of equal length. They have shorter and more robust hand and foot bones. They tend to have joints that are more adapted for stability instead of flexibility. They don't need their tails for balance. Many of these primates still have a tail, but it is not prehensile. So it's it's kind of a useless tail, I guess you could say. So this means it's a tail with no grasping abilities. All right, then knuckle walking. So this is a more specialized form of terrestrial quadrupedalism that involves walking on the knuckles or the forelimbs. So essentially you're up on your knuckles like this. So this is a specialized form of locomotion that we only see in the great apes, gorillas, chimpanzees, and bonobos. Orangutans do it to a degree, but their form of locomotion is called clambering. So it's kind of a variation of knuckle walking. I'll show you a video here in a second. But they do have forelimbs that are slightly longer than the hind limbs, simply because when you're looking at them, they're kind of, their backs are kind of sloped like this. Okay, so this is a chimpanzee knuckle walking here, and then this is a gorilla. The chest is elevated high off the ground when the hands are on the ground, and they're walking on the dorsal surface of their middle phalanges. So our finger bones, those are our phalanges. These are our proximal phalanges. These are our medial, or excuse me, our not medial, middle phalanges, and then our distal phalanges are our fingertips. Okay, let's watch a little video clip on this one, because this one, I like this video clip because it actually is going to show you some stunt actors or stunt trainers and how they're training the actors to perform in the Planet of the Apes movies. Okay, so it's going to show you how knuckle walking varies between chimpanzees, orangutans, and gorillas. All right, let me pull this up.
Hi, I'm Norm with Tested, and I'm here with Terry Notary.
All right, so this is going to show you the various forms of knuckle walking that you see in the great apes.
You're the choreographer, the stunt coordinator, the guy who teaches all the other actors how to be an ape.
Yeah,
and you're in the movie.
Yeah, I play Rocket in the film as well. Yeah, so it's a lot of hats, but it was fun. It was a lot of work. We really tried to make something special, and I hope the audience likes it.
So, what do you tell an actor like Judy Greer, who's in the movie? How does she become an ape? What's the training regimen?
Yes. Well, it's funny because when actors come in, they say, "What do I do? What do I do to be an ape?" And it's not about doing anything. I tell them it's about undoing, and it's about figuring out what it is that makes us human, and you peel those layers away, and what you're left with is an ape, an animal. And so we're all animals, and we all have this deep-rooted, connected animal in ourselves, and that's what apes have. They have a calm, a quiet, and a sense of presence that is so deep. It's almost like tapping into a deeper frequency, within you.
So all the things I learned through school, good posture and everything.
Yeah.
All the manners, take that all away.
Take it away. Yeah, exactly. All the social conditioning that you've been subject to, you realize that it's just a product of our environment that has made us given us an identity so that we can go out and succeed and be successful and survive in this world.
And don't mind the spandex suit
Exactly.
with the dots on it.
Yeah.
So you have props
So,
also
yeah,
that
yeah.
you use to instruct them. These are
So
actually
these are
for
arm
the movie.
extensions. You want to try them?
Yeah, absolutely.
Okay, cool. So here's a left and a right.
Okay.
And so these are some of the arm extensions that we've made that help us with the anatomy, so we're more anatomically similar to the apes because they
Okay.
have longer arms and shorter legs than us. So
you're
when you
supposed to
start,
walk
start over
around.
here. We'll start from the basics, and we'll start in with a quadruped run. Okay.
Okay.
So a little bit wider stance here. Yep. Good. So I want you to go left, right, left, right, left, right, boom, boom. So it goes hands, left hand, right hand, boom, boom.
Right.
Good. Not bad.
All right.
bad. That's pretty good. Okay, try it again. And now I want you to start to lead with the right shoulder. So this will be your lead arm. Your arm will be lead. So you're not going to be straight ahead. You're going to kind of lead and crab it. We call it crabbing. So left, right, boom, 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 boom. Good. Not bad. Yeah.
So how
Yeah.
are the different types of apes and different animals? How are they?
Yeah.
How are they all different?
Well, they all have a little bit. They're quite different, and I can do a demo for you if you want. The orangutans are incredibly economic. They're like the second most economic animal in the world next to the sloth. So super economic. So
Sort of
they're
energy
really really slow, and there's this sort of comics sensibility to them. And then gorillas are much more postured. They have a tendency to sort of, they have this bravado with a lot of show, and they sort of pull themselves along. And chimps are much more active, much more wiry, and they're just like.
Now, how does someone get into motion performance and motion capture as an actor? Is
Yeah.
that something like, do you do traditional acting first, or is that like other schools?
Theater is always great ground. Yeah, acting classes, and it is acting. It's just straight plain acting, and the costume goes on after. So,
Awesome.
yeah.
Well, thank you so
Yeah.
much, Tara. This is amazing.
Thank you.
And the
Thank you
movie
very
comes
much.
out soon.
Nice to
Thanks.
meet you. Thank you.
All right, I like that little clip because it shows you knuckle walking, but it also kind of shows you, interestingly enough, how somewhat easy it is for us as humans to recreate this form of locomotion that's used by our closest living ancestors, or our living cousins, the great apes. So that's why I like that little clip for you guys. All right, so one last thing I wanted to show you before I have you guys do a little bit of work in your breakout rooms is this concept of sexual dimorphism here. So I know we've talked about it a little bit, but just to review, sexual dimorphism is essentially the physical differences between adult males and adult females of the same species. So that could simply mean differences in overall body size, but it could also mean differences in specific characteristics, like differences in the canine size, the robusticity of the body, the robusticity of the sagittal crest, for example. So it just simply means differences between males and females, and it could be differences in coloration as well. So we tend to see high degrees of sexual dimorphism in primate species with polygynous mating strategies. So polygynous, so poly means many. So polygyny is one male mating with multiple females, whereas polyandry would be one female mating with multiple males. So polygyny we tend to find in a lot of the old world monkeys and the great apes. And typically when you see polygyny, there's high competition for access to mates, access to territory, and of course, access to females. So we tend to see these high levels of SD in species like baboons. I'm going to show you a little clip on gelada baboons here in a moment. And we tend to see low levels of sexual dimorphism in species that are polyandrous or monogamous. So some examples of that would be some of the platyrrhines and, of course, the lesser apes. And humans, modern humans, comparably, if we're comparing ourselves to the other great apes, we tend to have relatively low levels of SD because our males are not double the size of our typical female. All right, so I'm going to show you guys a little clip here. This clip is going to be gelada baboons. So a couple things I want you to look out for. So it's in your notes, but I want you to look out for how are the males signaling their dominance? So what do they physically do to signal that they're dominant? So look for behavior, look for minor things that they might be doing with their facial expressions. So how are the males signaling their dominance? I want you to keep an eye out for how are the females involved. So the females, even though they're not dominant in this particular mating strategy, they are still important. They're still involved in the all-encompassing dominance hierarchy, the game. So I want you to think about how are the females involved. So those two things, just focus on those two things. How are the males signaling their dominance and how are the females involved? And also keep an eye out for the bachelors. There's going to be a group that's called the bachelors that will also be part of this clip here. All right, last clip for today, and then I'll give you guys a little bit of time to work in your breakout. Let me find it here. Oh, I forgot to pull that one up. Let me pull it up real quick.
And their young, a harem, gathered. Groups of mothers and their young, a harem, gather together to form troops of up to 800 monkeys. Gelada's hands are usually busy plucking grass instead of grooming, so to keep in touch, geladas have become the chattiest of all monkeys. The gossipy banter can sound to scientists like sentences with words or even names for each other. Most agree it's often used to defuse tension. And in geladas, there's a lot to be tense about. There are gangs of young males trying to steal away the women from the family harems. Each handful of females is guarded by a single male, the harem master. The spare boys try and tempt the girls away, hoping the resident father figure doesn't notice. The males flash teeth at each other. They may fight, but it's usually just showing off in case the girls are watching. There's a lot of flirting on both sides. And then, if an innocent-looking female is tempted to wander off past her guardian, he has to decide what to do. Girls mostly sneak off secretly for affairs. This is a blatant challenge to his authority. The illicit couple just sit. The suitor seems to be using his hand to hide his grimace. He probably doesn't want trouble. Chimps, baboons and macaques may also try to look innocent when they break the rules. This is a complicated social problem. Using your brain to control societies is called Machiavellian intelligence, after a 16th century courtier who wrote on manipulating political power. Instead of launching into an attack, the politician here tries to grab a baby. Monkey etiquette dictates nobody attacks anyone holding a baby, so they're like living flak jackets. The mothers are worried and quickly scoop up the youngest. Here, the two males face each other. The family man backs towards one of his more loyal wives, calling for support. One of the youngsters suddenly switches from mother to father. This should calm things down. With the youngster attached, the father's protected, and the harem should unite. But it can go wrong. The youngster is slipping off. The family are frantic. The harem master has no protection from attack. The bachelor is finally driven off with a little help from the mothers. But the fathers are meant to guard the precious young. He knows he's in all sorts of trouble. If the infant dies, the mothers may not support him again. Our brain, too, wrestles with our own similar problems. We are as social and as competitive.
All right, so I'm going to let you guys answer those questions in your breakout rooms. So in your breakout rooms, I'm going to stop share here and stop the recording. So in your breakout rooms, of course, if you didn't finish